Okay, we've got modeling with quadratics. So what we're going to look at today is maybe like a worded question which involves some form of quadratic, and then we've got to answer a few interesting questions about that there. So we're looking at some sort of real life situation. We've got a stone being thrown off the top of a tower, and the height in meters of the stone above the ground after t seconds can be modeled by this function over here. And then we've got 4 separate questions that we need to answer. But before we even answer that, what we're going to do is try to sketch what this actually is, or what it actually looks like. And we've covered lots of sketching, so hopefully we can actually produce a decent sketch of this function here. So let's do that. Now, before we actually start, what I'm going to say is usually we see functions written as y equals, and then maybe like 2x squared plus like 10x minus, I don't know, 6, let's say. So what we're expecting is that when we sketch this, we have a y-axis and an x-axis. Now clearly you can see here we don't have y's and x's. Instead what we have in our function here is h's and t's. So all we need to realize is that the axes are not going to be really x and y axes anymore. They're going to be h and t axes. Okay, so I'll leave that up there, and now let's try and create a good sketch of this. So let's just write the function now. H of t equals 10.2 plus 2t minus 5t squared. Okay, first thing, the general shape. Now you can see here it's a negative t squared. What does that mean? It's just like a negative x squared. So it's going to be some sort of sad face or n-shape quadratic. Next, let's find the y-intercept. But instead of being the y-intercept, it's going to be the h-intercept. So to find that, what we'll need to do is put t as 0. So let's do that now. So we're looking for t as 0. So that would be 10.2 plus 2 lots of 0 minus 5 lots of 0 squared. So then that means h of 0 is just going to give me 10.2. So I know now that my graph crosses the h-axis at 10.2. Next thing to do would be to find the roots, or where it crosses the x-axis. Except for our function, there's no x-axis, it's a t-axis. So all we're going to need to do is set h as 0 now and solve this for values of t. So we'll say 0 is equal to 10.2 plus 2t minus 5t squared. Now to solve this, I think the best thing to do would just be put it in the quadratic formula. So we'll just rewrite it so that the 5t squared is at the front, and then that, then our 10.2. So using the quadratic formula, we can say a is equal to minus 5, b is equal to 2, c is equal to 10.2, and then just plug that all in. So we'll have x is equal to minus 2 plus or minus the square root of b squared, that's 2 squared minus 4 times by minus 5 times by 10.2. And then divide that all by 2 lots of minus 5. So if you pop that into a calculator, we should get 2 answers. So let's find out what we get. So we've got that. So we've got minus 5, 2, right. So our first answer comes out as 1.64. That's the 3 sig figs. And the next one comes out as minus 1.24 to 3 sig figs. Okay, cool. So those are our x values, but remember for our equation over here, that's going to be t values. So t is 1.64 and t is minus 1.24. Okay, fab. Now, the last piece of info that we need is the turning point. So that very point over there. So where is the turning point and how do we find it? So to get the turning point, what we could do is complete the square. So we need to complete the square for this over here. So let's quickly go and do that as well. So h of t is equal to minus 5t squared plus 2t plus 10.2. So to complete the square, we have to factorize out that minus 5 to begin with. So we'll be left with t squared minus 2/5 t plus 10.2. Next, we can go and complete the square inside here. So we'll have h of t is equal to minus 5, and then t minus 1/5 squared minus 1/5 squared, and then plus 10.2. Now we'll just go neaten this up. So we'll have h of t is equal to minus 5, and then t minus 1/5 squared minus, now a fifth squared is 1/25, so there we go, and then plus 10.2. Now we'll multiply through by the minus 5, so h of t equals minus 1/5 t minus 1/5 squared plus, that's going to be 1/5, and then plus 10.2. Last little bit is let's combine these two bits together here. So h of t equals minus 1/5. Minus 5, and then t minus 1/5 squared, and then add that onto there. That's 0.2, so it should be plus 10.4. Okay, great. Now that we've completed the square, what we can do is find the turning point. So remember the turning point, we just go in here. To find the x coordinate of our turning point, we just change the sign of this number, so it's just going to be 1/5. And the number on the outside just gives us the y coordinate of our turning point. So our turning point is 1/5, which is 0.2, and then 10.4. Okay, smashing. So with all of this information here, we can create a brilliant sketch, and that's going to help us to answer this question and make it actually really simple. So h-axis, t-axis. Right, first thing we know is it crosses the h-axis at 10.2, so we can put that in here, 10.2. We know it crosses the t-axis at 1.64, I'm going to put that here, 1.64, and at negative 1.24. And we know the turning point is at 0.2 and 10.4, so a little bit higher. So 0.2, 10.4. There we go. So if I was to draw a graph in here now, I can draw something like that. Perfect. Now, what does 10.2 represent? Now 10.2, as you can see there, is the Y-intercept or the H-intercept as we have here. And what's so special about that point? Well, at that point, t is 0. So what does that mean? Well, that's the point where the ball is being launched from. That's the height there. So what that tells me is this must be, well, probably the height of the tower, because that's where it was thrown from. So height of the tower. So at time 0, where is it? Well, it's at the top of the tower, about to be thrown off it. Next, after how many seconds does it reach the ground? Well, can you imagine that's the path of the stone, and it hits the ground over there after 1.64 seconds. So we've actually got that answer already, 1.64. Now, you might be thinking, oh, why didn't we use that one? Well, because remember, this is the t-axis, which represents time. And you can't have negative time. The ball's not being thrown backwards here, it's going that way off, right? So time is positive, you're throwing the ball that way. Next, write h of t in the form there. So just complete the square. So actually, we've also got that answer down here. We just need to put the 10.4 in front of this because they want a at the front and then minus b lots of whatever. So that there is just going to be 10.4 minus 5 lots of t minus 1/5 squared. So there we go, we've got that answer too. And then we need to find the maximum height of the stone and the time at which it is at this height. Well, we've also got that as well. We know the maximum height is just 10.4 meters. So 10.4 meters. And at what time was it there? Well, on the time axis, that's there at 0.2 seconds. So at 0.2 seconds. There we go. So we've actually got all the answers there, just from creating a really useful sketch. And hopefully once you've sketched it out, it makes it easier to see what you need to do. So that's one of these modeling questions done. Hopefully that all makes sense. And I'll catch you again for one more modeling question.